Here is a very interesting question, question number 4. A classroom has capacity of 20 students. Part A of the question is, write 4 possible combinations for the number of boys and girls in the class. Part B is, write an equation to represent the situation. And part C is, plot your data on the graph. So we will start with defining our variables. So that's always the first part when we are doing linear relations, right? I hope you have learned from the previous 3 videos how to do or how to define variables and then make table of values, and after that plot a graph. We'll follow all those steps here, and I'd like you to do them before me and then see how much you've learned by now. So first thing is, a classroom could have boys and girls. So let's define the variable saying let b equals to number, I'm writing in short, and number of boys, and let g be equal to number of girls. So that is how we have defined our variables. As we know that the classroom has a capacity of 20 students, that means boys plus girls is equal to 20. So that gives us our equation, correct? Boys plus girls is total number 20, right? Now part A is write 4 possible combinations of number of boys and girls. So we could write like if boys are, so we'll write these values in a form of table. Let me make a table here. So we'll make a table like this, and we say, well, let me write boys here and girls here, and then each should add up to 20. So if I say there are no boys, that means how many girls do we need? 20, correct? So, well, why not? No girls. Let's say 0 girls. In that case, number of boys will be 20. So that is how we get the combinations, right? We can have 10 boys and 10 girls, correct? Makes it 20. Or we could have 5 boys and 15 girls, making total of 20. Why not? Let's write here 12. And 12 boys and how many girls? 20 minus 12 gives us 8. So that gives us 1, 2, 3, 4, 5 set of values, correct? Now these set of values can be represented on a graph, correct? So we will do that. Now let's go through our questions. First is write 4 possible combinations for the number of boys and the girls in the class. Now that is of our combinations for the number of boys and the girls in the class. Part B is write an equation to represent the situation. We actually started with part B, and the equation is boys plus girls equals to 20. And to write the equation, we need to define variables, which we did, correct? So this is a better approach. First define variables, write equation, then your table, right? So we got up to A and B. And third is plot your data on the graph. So we have a graph here. Normally on the x-axis you write independent variable. Here both variables are same strength, correct? Boys or girls. There is nothing called independent or dependent. In fact, both are dependent on one another. So we could write anything on this axis, right? So let's write boys here. So variable for boys is b. So we'll write b, and we can write what does it mean. We say number of boys. Similarly, we will write here number of girls, and we'll write g here as the variable name, right? Now to plot the graph, we need to plot the points which we just got. So the first point is 0, 20. 0 for boys and 20 for girls. Let's see how many divisions do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So of course not 20. So let's say each is 2. If I say each is 2, so I'll write my scale here, correct? Scale is each is 2 for me. I'm writing 2 here and 2 here. So it becomes each division of 2. Now let's again count by 2's. So you got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That gives me the first point. Next is 5 and 15. So 2, 4, so 5 and 15 is in between. So we'll forget about that for the time being. Let's take the last point, 20 and 0. So again 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So that becomes 20, right? So we get 20 here. So 10 divisions will make it 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 will make it 20, right? Because the scale is 2 per division. So I'll write 20 here and 20 here to be very specific. And once we have these 2 points, we can join them with a line, correct? As you know, to draw a line, we actually need minimum 2 points. So we got the minimum here. We are taking advantage of that and drawing. It is a good practice to plot all the 5 points first and then join. But we are joining it so that we check it out whether other points are correct or not. So that is the idea. For you, you should first plot them and then join. So let's look for 10 and 10. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. It works, right? Similarly, you'll find others will also work. 5 and 15. 2, 4 and 5 is right in between, right? And then 2, 4, 6, 8, 10, 12, 14 and a half, which is 15. So we can get all the points here, right? So that is how you can plot all these points, and you will see that all the points will lie on your line, correct? So that shows that this relation is linear, right? So what does this graph show us? It shows distribution, or it shows number of boys and girls in a class, right? So in a class of 20. That is what it shows, correct? So these are possible number of boys and girls in a class of 20. So that completes our answer to this question. Important things here are: define your variables, write down a clear equation, and then with the help of equation, get some points, values. On a graph, try to figure out what should be the scale. And once you decide the scale, as we did here, each division is 2 numbers, whether it's 2 boys or 2 girls, right? So that is the scale. And since in this particular case we don't really have an independent variable, so we have a choice. We could put B here or B there, or girl here or girl there. So we made a choice and then plotted the points and connected them with a line, which is a huge mistake. This line indicates that it is a trend. Actually speaking, what we should have done, we have to draw only the points. So it's a good time for me to correct it. So you get some points, don't connect. Correct? Don't connect. So what we get? This. Because you cannot have 1.5 boy. Do you understand? So you get some points, and of course, since we have taken scale of 2 per division, and therefore we will have points in between, right in the center also, as we saw here, 5 and 15. That will be right at the center. So we will get set of points like this. In fact, since I did a mistake, I am now plotting all the possible points. So these are all the possible points for us. So how many combinations we can have? We can start with 0 number of boys, then 1 number, 2 number, 3, up to 20 boys. Do you see that? That will give us the whole list of combination. So boys ranging from 0 to 20. So in this question, what we also see is that the number of boys and girls are limited to 20, right? So they cannot be more than 20 boys, or they cannot be more than 20 girls, correct? So what we learn from here is that we have a limiting criteria. So let's write down here for maximum equation. So maximum number of boys or girls, number of girls is equals to 20. That is 1. Second, do not, when we plot the graph, so we write do not connect the points, right? What is the reason for that? Since we cannot have 1.5 boy, they are discrete values, numbers, right? Since they are discrete values, we cannot connect them. What is this pink line showing us? It is showing us a trend. And what is the trend here? The trend here is that if number of boys increases, number of boys increases. The trend is if number of boys increases, then number of girls decreases. So that is the trend, right? So that trend is shown with the pink line. Don't think it is a connection as we did earlier. It was a trend. Think it like that, okay? Now, and maximum number of points which you can get on this graph is from 0 to 20, all with discrete values, correct? So there will be 21 points, correct? If you count 0 to 20, you'll have 21 points. So that is all we learned from this. I hope you understand and appreciate how this graph should look like and why we are not connecting it, and thirdly, how the trend is. Thank you and